Hello and welcome back to Poor Man's Electronics Bench. I am going to endeavor to start an episode with multiple parts on my exploits of working on two Sencore LC53 Z meter capacitor inductor analyzer units. This first part will be a video of the creation of a good test lead to use for these units, as most auction item units sold will not have any cords or original accessories with them, and these meters require a low capacitance cable for them to calibrate down to a 0 for single and double-digit picofarad measuring accuracy. I will cover my selection of cable, the parts I am going to use, and the assembly process I used in order to create my cables, and maybe this information will help to give those that would like to make a cable of their own some guidance to pursue the project. I hope you continue to view and enjoy the content. As you can see, I have a varied amount of items on the bench. What this hopefully is going to accumulate itself into is a working version of a test cable for the LC53. I've done a little tinkering with the sample of a meter that I have that's working, and I have determined that about the average capacitance it likes to see on the test lead, because it's going to see some. You cannot have unless you have two separate leads going well into a component from the tester, which can be done, by the way, but I'll get into that later. The test lead itself is going to be a coax cable that has a capacitive value that the meter can be adjusted for to a 0 to start things out. And playing around with the meter a little bit, I noticed about a good value of that capacitance is about 30 pico or picofarads, depending how you want to say it. And one of the few types of coax that can pass on a connection at a lower capacitance is an RG62 cable, which I have a quantity of 8 feet of. And that means it's about 2.5, a little over 2.5, close to 3 meters. And I found a spec sheet on that cable online, which I can give you a quick view of. And the rated capacitance for that item is, so it just has a per kilometer, nanofarads per kilometer. It's 45 nanofarads per kilometer. So we have, if you change kilometers to meters, that would be a division of 1,000. And if you change nanofarads to picofarads, that would also be a division of 1,000. So that gives you at let's say 2 meters, give or take. It's giving a little more. It's more like 2.5 meters almost, but not quite. Should be in the ballpark of 90 to 100 picofarads. So I have this capacitor tester, which is pretty good at doing lower values. I can zero this with the leads totally detached from each other. It comes up with a 0.02, 0.03, and this is fairly insulated on the far end. It's not a short. And if I connect to the length of cable that I have, comes up with 91, 90, 89, about 90 picofarads. So if I section this off into 3 separate identical lengths, I should get about 30 picofarads, give or take. So that's going to be my next attempt at doing things, is measuring this out into 3 comparable lengths, and I'll be back in a second after I do that and cut it. Somehow or other I had a boo-boo and figured out that I thought I had 8 feet of this cable. I only had 7, so I thought I was going to try to make two cables and have a third stub. Mail carrier alert, sorry about that. So this piece here is about 3 foot 4 inches long, and the measured capacitance on it just can't be too high because a regular coax lead, I'll show you in a minute how high it can get. This one's dialing down to about 50 picofarads, and I'm not sure how well I have the end cleared here. That other cable might be a little lower in capacitance for some reason. You want to be able to make this long enough so you can keep the meter a little bit away from whatever you're working on a bench in a fixed position, and then get to something, test to connect to it if you lift one side of the component, especially at a lower value. If it's a higher value, it doesn't make a difference. But this is still a pretty low capacitance compared to some other leads I've got. Another one handy here. This is a standard audio grade. Cable with the BNC, and you have connections to add different things on. And if I wanted to check the capacitance on this one quick, we're talking for about the same length of cable. It is 105 picofarads, and it's that adjustment knob on the front of the LC53 will only adjust to within a certain range of capacitance. From what I saw, about 30 was a sweet spot, but there's a possibility I can make an adjustment to get it up to 45. I think 45 was doable, because it looked like I can go have it read a positive 16 on something. If not, if this is too long, I'll have to make an attempt at shortening it, but I'll find out when I hook it up to the meter. So looking at that, the only other thing I wanted to do is just do a quick check and make sure there's no resistive faults in the cable. So we're going to go to my favorite, using a digital voltmeter that is capable of measuring nanosiemens, and checking across the leads. And this is settling down to below or about 100 gigaohms of conductance once I stop moving it around. There we go, we hit our sweet spot. So 100 gigaohms of comparative resistance as far as conductance. So that's an open lead on a cable. And then going through things, I just want to show you a few things. I'm going to be using fairly good quality components. These are Cinch connectors made for RG59 or 62. The only odd thing is this says a 75 ohm BNC. Well, this cable is not 75 ohm, it is 90 something ohm according to the specifications. So not that it makes a big difference, because we're not transmitting an RF signal along length. We're just wanting for a good connection on a low capacitance signal. And these clips are sourced from Mueller. I just want to build some stuff that's a very good quality. This is Pomona test lead. You'll notice it has the white separation on the insulation on the inside. So I'm going to go through the first part of putting the BNC connector on. These are fairly easy to use, but you do need some sort of hex style crimper that will crimp this sleeve on after you get things in place. Like a slide. Don't forget, if you don't have a finished end already, don't forget to You can get away with sliding this on. If your other end is finished, you have to slide it on backwards before you do your stripping. Now, stripping these is a couple of step process. You have this particular connector just has a insert for the conductor that it should lock in with, and then the second part, I'm not sure how long this is going to or should be, because the specifications for making BNC connectors, and I've had some experience with it because as a technician for AT&T, I was actually at one time certified to put BNC connectors properly onto coax cables, because part of the old Sonnet equipment that we installed required the manufacturer on site of some bulk cabling. And normally what would happen is this one pin in the connectors that we had was loose. You would crimp that on here separately. This measurement and this measurement had to be set to a standard to use with that connector. And I'm not sure how far this conductor slides up into here, but I'm pretty sure it's going to lock in on me. We're going to give it a push and see for right now. It's not going in too far, and it's definitely not locking. So what I'm going to try to do is remove some more of that. My wire stripper's handy. One nice part about this is at least it doesn't involve any heat. Take 2 cuts on that polyethylene insulation, one with a larger one, one with the other one. If you notice, this is silvered a little bit. I took a little bit of liquid tin and put it on there in lieu of tinning it with a soldering iron. So in this case, the braid should get up on there better. Okay, we got to the point where that's as far as we can go, so this doesn't really lock on there well at all. It's just going to rely on, and if you can see, there's a little gap. So what I'm going to do is just cut a little bit off of this tip, and then making sure that there's no braid interfering between the 2 connections. I'm going to slide the sleeve back up where it catches all the braid, and choose the appropriate size crimp. This particular crimper is a cheap overseas sourced one, but hopefully it's going to do its job, and that should give me a good connection. And I will put a piece of heat shrink over this part of it in order to do a little strain relief, and also to keep things in place a little better. Hopefully over time that it won't dwell off from its connection. So I'm going to pause and do that, and then set up for the connectors on the other end. And here's where some arts and crafts comes in for making cables. The first thing you want to do, since you're probably going to have a hard time sliding heat shrink over the end, is slide some down towards your BNC prepared end already. I put one piece that was going to give some coverage, and both of these have an internal hot melt glue adhesive to them, which is nice because they really stick on there and form some more protection. And in this case, I chose to cut back about 5/8 of the outer insulation to expose some braid, and I've got a couple of reasons for that. The first off is I'm going to be able to expose a little more of the inner conductor. Tried my best to just roll over I didn't try to vigorously cut. I just rolled over this razor over that, and I still got some some braids cutting loose, but in the grand scheme of things, it's not going to hurt because there's never any large amounts of current going through here. Make sure that there's absolutely no outer conductor braid going anywhere. This insulation is a very delicate polyethylene with a low melting point, and it's something that you really don't want to expose much heat to. But you still want to keep it insulated from the outer shielding as much as possible. And what I'm going to do to accomplish that is I'm going to use some small silicone tubing, cut the length. I want to make a piece just long enough to leave me some uninsulated wire to go and connect, as I will show in a second. So I'm going to cut off a good majority, probably up to about a ½ inch of this inner insulation, and do it in 2 cuts with this particular stripper. Oh boy, one more. You gotta get it on the smallest wire, and got a couple of bites on it, and I think I got it. Okay. Probably zoom in a little on what I'm doing here. Now that I've got that portion of it done, I could even go a little more, but I'll show you what I'm going to try to accomplish here in a second. Making a first cut just to cut through most of the insulation, then a second cut with the smaller final gauge cutter. Trying not to nick or harm anything. I'm going to then take a piece of the silicone, probably about a little over half of the length of that exposed conductor. Slide it on here. It's funny because although these look like they have similar properties to them, the silicone will not be affected by heat. I can even go a little more in that inner conductor. I keep on making these cuts. Measure once, cut 5 times, as they say. I don't do this every day, so it's not like I'm going to do it right on the first shot. Okay, so that's what we have. That is probably about a little over ½ inch. That must have been like about a 3/4 amount of braid I exposed. That's a little over a ½ inch there. And I cut a small piece of silicone, so I'm going to put that on here. When I'm soldering this braid, it's also going to apply some heat to the polyethylene jacket in there. So what I'd like to be able to do is cut open my sheathing for about a 1/4 inch or so. What that does is it allows for some expansion. And then I saw one person, Mr. Carlson, make a cable like this. He inserted a piece of tubing, Teflon tubing he had, that was large enough to go into things. But what I'm going to do instead is I have this Nomex paper left over from a bunch of other projects, and I can put that in place, and that's a good heat insulator. So now we have the chore of connecting the inner cable together, and what I'm going to do is put some flux on this guy, and then I'm going to try a little something similar to what Mr. Carlson did, except with a twist. I'm going to take one of my pieces of brass tubing that I use for connecting everything. Try to get all of these strands in here. Which I did. Amazing, I got it. And then I'm going to push this center conductor inside here, and it'll also go a little bit into the lead itself. And I really like a process like this because I am a big fan of a secure mechanical connection when you're doing soldering. I don't think that tack soldering is ever a good idea for a permanent connection. Something in this case, the better you can get your connection. In fact, I can even cut that silicone down a little more just to get that center conductor in a little bit. Should go to a manual focus, but then I'd have to make sure I'm holding things right at the right spot. So I'm going to go just a little shorter on that, push this down all the way to my polyethylene. And this way I can go, and that center conductor will go into the insulation just a little bit more. I do like this idea in general as far as giving a good straight connection on a wire. And it looks like it's going with a little bit of resistance. And what I can do, if I can hold that in place and give it a squeeze, and then I wish I had my other solder, my self-heating solder gun available, but I don't right now. I do have another iron heating up though. I'll have to get it into position. My old bench Heathkit guy. Whoa, sorry about that. Where are we at here? Here we are. Okay, clean the tip off on him. That's one thing unique about this iron, is that the way this stand is built, you can makes a nice third hand. A little dwell time with the solder. Huh. Looks like my center conductor might have went off angle and went outside the crimp, but it's really not a big deal. I have a good mechanical connection and do have some solder straight up into it. I made an attempt and failed this time. I'm not going to bother to rework it though. So I do have a piece of red glue infused heat shrink to go over that portion. Could even pull it down here a little bit. It's a very well insulated joint. And then the next part of the project is to centralize enough of this braid to make a connection to the black lead. And that will heat up a bit when it's, or it will heat up a lot actually. I need to strip a portion of my black wire. And use a, oh boy, use a little flux. Okay. And I have to get a little bit better lead prep here. I would say that's pretty good. A nice little mechanical connection there. And apply some solder. You apply enough heat to make sure you see it wicking into the braid, and then you've got a good joint. And it looks pretty good. So that one can also get a piece of heat shrink. And yeah, I know I have some errant braids there. It's not perfect, but in the long run it's going to perform just fine. You can always trim those off quickly. No harm, no foul, because they're well insulated from the inner conductor. And if I straighten them out, I actually have a good lead length. I cut these about 3.5 inches exactly on both parts, and then this is where my, just in case things got a little big for some reason, that I slid those other two heat shrinks on there, but at least I know I have them available regardless of what happened. I just have to get the smaller one slid down the cable first. There we go. The original manufacturer, I'll try to get a little adhesive there and there, and the original manufacturer leads are joined and then encased in a plastic resin from the manufacturer. It looks very professional. This one will look acceptable. Give it some good heat and make sure you see some of that glue flow around. And then the final One more piece over everybody. It's nice to see that little bit of that heat shrink glue oozing out. So I'm going to let this cool down for a little bit, and then I'm going to take a look at the process for gluing or for soldering one of those Pomona or Mueller leads onto the end of the cable here. So I'll be back in a little bit. I ran into a little bummer of a modification already. First thing you find out is your entrance size for the cable for the Mueller clip is nowhere near as big as it needs to be for the Pomona cable. So I've got a small drill bit here, a 5/32 that looks to be the right size, and I'm just going to exercise drilling this out by hand. Such a thin small piece of plastic, it's not worth trying to use any power tools with it, so I'm going to do a little work at doing this, and I'll get back to you in a minute. Okay, what I did is I had a drill bit set with different size bits, and I worked my way up from a 7/64 all the way up to the 5/32 using a, that's upside down, using all 4 bits and just doing it by hand. And that seemed to get me where I needed to go. I got the wire into there without much effort now, but a little bit of a problem getting it straightened out, so you're going to need some needle nose. Try to get in there and get a yank on it. A little problematic because the opening in the bottom restricts the amount your needle nose can spread out to grab something as well. So I think I got a good, just about there. Oh boy, there we go. I guess once you get it to make the turn, you can go through in a push. And then after that, it's just a solder joint onto the top of one of these. So I'm going to perpetrate that off camera, and then do the other lead, and then I'll have hopefully I have a working test lead to use. I can hook it up quick to my coverless meter and see how it behaves. So if you want to see that, please stand by. Oh, I lost a little footage getting things put back together. I did want to show you that there's a little solder connection that needs to be made inside, and then you'll need to make a little removal of some solder and excess wire. Maybe I could show you here. Let's see the wire I've got soldered in, and it's got a good joint on the inside. Zoom in and focus there. It's got a really nice joint on the inside, and the outside you're going to have a little wire stick out. And what I did is I took a pair of flush cut cutters before I pushed this piece on there and cut that as flush as possible, because if not, it's going to interfere with the ability for you to put the slightest cap on. And then getting the cap on, it's a good idea to grab it with a pair of needle nose and get a start to everything. Pulling your wire a little bit as you go. And you're going to get to a certain point where it's just going to be just going to be brute force and pushing the top in and pulling your wire lead out a little. When you're done, hopefully you'll get both of these to seat as well and equally as possible. This one probably can use a little more of a push. There, those are pretty equal. You can tell that they're not, they just got barely a little bit of that slat. And you might find out that your end gets out of alignment a little bit and doesn't retract all the way. So you can always just take a pair of needle nose pliers and line that back up. I had to do that with the red one, but that looks to be it. That's the finished product with the end on it. Some may think that the hot melt glue is a little unsightly. You can always peel it off after it cools, but should give a durable cable. And just to double check what the capacitance might be on it. Let me get my solder out of the way here. I'll go and zero the leads again. Below 1 picofarad. And right now I have a cord that comes up with about 49 to 50. So the only thing I'm going to have to do is try to zero my meter out as well as possible. We'll go over and see if I can do that next. And I have a good news day, because after all that work for making these leads, this seems to be long enough where I can put this on the backside of a bench, hopefully on a shelf, and then connect it to things. I can zero the leads quite easily using the value adjustment knob. Get right to a 0, and getting into the negative, it seems like there's a certain value of probably at least 20 picofarads that needs to be connected to the front of this meter for that oscillator to start, the internal oscillator to start working to make the measurement. If not, you get a negative value of 2.2, and it won't go or show any lower than that. But once you get a value high enough to get that oscillator to start to work, then, which this cord is, then you can apply a 0 range to things. And apparently the cord's been manufactured fairly well, because I can, whoops, took my finger off the button. Well, let's see, moving. Probably have to get a 0 value in whatever position it's in. Then I'm going to hold that down, and then moving the cord around makes the value change a little bit. If you're trying to read such a small value of capacitance, it's probably best that you use something, or zero it when you get it close to the item and then connect it if you're going to leave things in a piece of equipment. But other than that, I'm pretty happy with the results from how the leads came out. Doesn't look any worse than any of the offerings that were made online for sale on eBay as far as aftermarket manufacturers, and I know exactly how mine was made and what type of components were used to make it with, and the quality of all the work, which I can't say about anybody else's builds because they're not disclosing it in a video. So we're going to go on to more work on this unit in the next parts of this part. This will be the conclusion of part 1A, and I'm going to continue the work on what I will call unit number 1, which out of the two units was not in working condition when I received it. It had its power cord cut off, probably because it had some malfunction issues. So I'll pursue working on that one, getting it back into a working state, and then doing some work to calibrate it and restore it back to good working order. Then the unit viewed here, which is unit 2, seems to be mostly functional, but it will go over getting some parts placed and calibration in it as well. So I hope you enjoy the content, and if you are interested in the work on these units, please feel free to subscribe and give me a like if you like the content. And please return if you would like more information about these units or other work I am going to do in the future. Thank you. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.